With the introduction of dimensional depot in Satisfactory 1.0, all-in-one one-click blueprint factories for personal storage are now completely busted. In short, with proper research we can access any produced item at any given time and place. Add to this one-click factory designed in Blueprint Designer, and then pile up small but immensely powerful new alternative recipe of iron pipes in Satisfactory 1.0. And now we have perfect combo of one-click factory with production of iron plates, iron rods, wires, cables, screws, steel pipes, reinforced iron plates, modular frames, rotors, starters, motors, and even automated miners. Dare I even say that this factory only requires connection of power and 480 iron ore per minute. One blueprint, iron node, some power, and you get dimensional depot full of 12 early to mid-game crafting components for personal use. That's it! Honestly, this box feels like complete magic. Press one button, then connect iron and power and you get everything. Like, what is this? What is this? Well, yeah. At least I spent like 20 hours designing this factory and then like 20 hours making this video, so you know there are quite a lot of effort in that. So, today in this video I would explain in detail how this blueprint is made, so you can repeat or even use this particular blueprint. This is rather advanced mid-game blueprint, and if you are looking for something a bit smaller for early game, I would highly recommend my video about 4x4 all-in-one iron factory. Alright, without further ado, let's talk basics. When you start design of a factory blueprint, you need to be aware of several things. At what stage of progression is your game? What is the preferred level of belts in your factory? What is the amount of raw resources available on the input of the factory? What is the size of machinery in the production chains? And finally, what are your overarching goals? In the case of today's blueprint, we are talking about game progression stage where you already have access to steel, dimensional depot, smart splitters and Mark IV belts. Something around tier 5 to 6. The time to finally fix that personal storage, get going dimensional depot and totally scrap that starter factory. One thing for this factory that is counterintuitive is 6x6 footprint of the factory. At the moment, Mark III Blueprint Designer is only available in tier 9, which is well questionable at best. Unless if the game would add extra several tiers, there is no point. Also, if you import any 6x6 blueprint from the tier 9 into as early as tier 4, it still totally works. Game never checks for things like alternative recipes, coupons unlocks, tier progression, research tree, and even blueprint size. It just plays the blueprint if you have enough resources. And then, if someone wants to follow this video as a guide for their own creation, I would highly recommend to use 6x6 Designer. If you are a beginner, it have way more space to work with, and making interesting exterior is way easier. Regardless the size, I design my blueprints in the endgame sandbox world, and only then I import them into a normal live sessions. Troubleshooting blueprints of such complexity is just not feasible on a normal live session, that's it. Just make sure that you have all the proper unlocks in the game session before using imported blueprints from the sandbox world. Alright, let's finally start with the schematics of this factory. On machinery front we will deal with the smelters, constructors, assemblers, dimensional depots and industrial storage containers. These dictate layout of 4 or 5 floors, and assemblers would be probably situated on the final floors. Smelters and containers logically would be on the first floor, while constructors somewhere in the middle. Pretty early on, I decided to place dimensional depot uploaders on the top of the blueprint. I just used conveyor belt elevators connected to the bottom containers. This was more like exterior design choice, and in this fashion I can just see the flow of produced items. Also, it just looks dope with LED backlights, so yeah, come on, this is like guilty pleasure of mine. Alright, we already know quite a lot to start our schematic. I'm using Satisfactory.com to design my factory layouts. Really awesome tools, and yeah, the person supporting this tool, you are an absolute legend. We already know the maximum amount of iron ore we can use in this factory. This number is 480 iron ore per minute. And 480 is the throughput of Mark IV belt. Mark V belts and aluminum are still quite far away at this stage of progression, it's pretty much no-go. The maximum amount of the iron ingots that we can smelt is also 480 for a total of 16 smelters, and then the next decision would be the alternative recipes. I want to push iron as far as I can. there is a small but very powerful recipe in Satisfactory 1.0 for steel pipes. Now we can make steel pipes from iron with iron pipe recipe. Then add to this existing recipe for steel rotors and steel frame, and we do not need any copper or coal for either rotors or modular frames. Then we need to do something with wires, and this is very simple. We just use the iron wire recipe to make stitch iron plates. This way we'll also avoid screws as much as possible. We can only use cast screw recipe without coal, so yeah, screws are best to be avoided, otherwise even 6x6 would be not enough. Then, if you look up standard recipe for stator production, we have everything at hand. In this production of steel rotors, we can combine the rotors and stators, and we can totally do the motor assembler. And final cherry on top of that is portable miner recipe for the assembler. With simple iron plates and iron rods, we can totally do the portable miners. So, with synergy of alternative recipes, we can easily convert simple iron ore into total of 12 items. Sounds like a plan. From this point, we need to determine production ratios for every item. I do prefer to work backwards from the top of production chains. Unlike in 4x4, in 6x6 blueprint, we have enough space to avoid any overclocking. This means that going towards 100% on assemblers makes way more sense. I would say motors in this blueprint is a bonus, and I know that I cannot really go higher than 50% on that, so yeah, 50% assembler there, but for stators and motors, one assembler each at 100% just make all the sense. 5 rotors and 5 stators per minute with a single assembler is more than enough when you have big enough buffer. Then I want to have not 3 but 6 modular frames per minute with use of 2 assemblers. Then for reinforced iron plates I decided to go with yet another 2 assemblers, and this sets us pretty much at 7.25 free iron plates per minute, which is quite acceptable. And lower tier items at this point is just the balancing act to hit even numbers with machinery. For example, 1 constructor for cables, 10 constructors for iron wires, 2.5 constructors for steel pipes, and 3 constructors for iron plates. This leaves us with the leftover iron for like 20% cast screw constructor and 50% assembler for portable miner. That's it. As you can see, with final steps in production chain and limited input of ore, we can easily determine everything in between. Obviously, production chain with several steps have a big wind-up time, and lower tier items would get into the storage a bit later, but this can be circumvented with the clever use of power switches, but more about that later in the video. Now, let's finally design the real thing. 6x6 designer can fit up to 9 storage containers in a row. I would not place storage containers for screws, portable miners and motors down below. Those are the least used items, and I feel like dimensional depot is more than enough for those, although I would still place the accessible buffer in form of storage container for each of those 3 items before the dimensional depot uploader. As I mentioned previously, with my exterior design I do place all my dimensional depot uploaders on the final floor. Next step is to place 16 iron smelters, and this is quite easy with 2 rows of 8 smelters that center in the blueprint. Output of iron ingots would go into 2 separate belts, although they would eventually merge together after feeding enough initial production steps. On the second floor, first I place total of 10 constructors for iron wire. They fit quite nicely in 2 rows of 5 constructors that center in the factory. 3 of iron wire constructors feed 1 cable constructor, with the last of the 3 constructors splitting wires into 2 separate directions. Then I place 3 constructors for iron plates and 1 constructor for iron rods. Up next, we need to start implementing verticality. On the 3rd floor, I start with the set of 3 constructors for iron pipes. Next to them, I place my 2 stitch iron plate assemblers. Then I place all the assemblers using the steel pipes and reinforced iron plates in the next line. This includes rotor and stator assembler with extra 2 modular frame assemblers. We have steel pipes and reinforced iron plates on this floor, so connections are pretty obvious, but for the rotors and stators we will need wire. On the 2nd floor, we have plenty of space for the vertical manifolds, so wire is quite easily connected from down below to our assemblers. And at this point, we have only 2 assemblers and 1 constructor left to be placed in our blueprint. Exactly those 3 previously mentioned items, the portable miners, motors and screws. So, those 2 assemblers and 1 constructor are quite naturally fit onto the final floor with those dimensional depo uploaders. Then add to this 3 more uploaders and 3 more industrial storage containers, and we are pretty much done with the machinery. Now we need to deal with connections, the funny part. It's not really hard to get final end of the belt to the container, but then there is an issue that arises. With no limitations for our final production tiers, we will not receive enough items before dimensional depo and containers are full. So unless the storage is full, we could not really produce enough items. And if we are not producing enough items, we are not filling up those storage containers fast enough. You know, it's chicken and egg issue here. This is why on the final splitter fork, I place smart splitter with overflow setting. For example, iron plates have final destination in the chain, before the containers, in the form of a portable miner assembler. At the portable miner assembler junction, I place smart splitter with overflow setting. Now, only when the final assembler and all prior assemblers are full of iron plates, the iron plates would go into the storage container and then dimensional depo. The same goes for every multi-tier production chain. This way of doing things have a downside. Obviously we are doing the actual manifolds with the splitter in the end, the smart one, but we are not doing the load balancing. So your schematic with those production ratios, those production ratios are not instant. Now your upper production tiers eats all the resources before they are full. So it can take up to an hour to balance the things out and to get those lower tier resources. This is why, for easy access to lower tier materials, I implement system of several power chains with power switches. For example, if I want to access rotors and stators before the motor assembler is fully loaded with motors and stators, I can disable the power to motor assembler. Just place that assembler beyond the power switch. Same goes for the access to reinforced iron plates. If I want bigger production ratios for reinforced iron plates, I just disable 2 modular frame assemblers. And then, if I want immediate access to iron plates, wires and steel pipes, I can finally disable almost all the assemblers at once. So my rotors, stators and reinforced iron plates are behind yet another power switch. Also here with total of 3 power switches, we need to implement a bit of more blindly obvious logic. If there is no power on reinforced iron plates, rotors and stators, there should be no power on modular frames and motors. It's kinda obvious. This is why my power connection for motor and modular frame power switches, they are connected to output B of reinforced iron plate, rotor and stator power switch. In simple terms, those 2 power switches for later production stages, they are behind the first power switch for earlier production chain. So when you disable your reinforced iron plates, rotors and stators, you also disable your motors and modular frames, because it kinda makes sense. At first, this feature looks like something unnecessary because, if you disable your lower production tiers, the higher production tiers, they will starve out of resources. But if you think about it a bit, you have the buffer and this buffer full of materials, so it's not instant. And then again, if you enable everything as it was before, so you have all the production chains enabled, you again end up in the position where you need this wind up time, so your buffers are not full. So once again, this is just done to make everything instant. So if you disable everything, everything is disabled instantly, not after 30 minutes. And then we have the switch number 4, which is the final switch for the power of the whole factory, because why not? Now we are done with the internals, and before we go and make awesome exterior, here is so-called OEM version of this blueprint. This version requires less resources and can be used as a template for different exterior of your personal liking. And both this OEM version and full version with exterior are available on my Patreon. OEM version is free and available right away, so you just need to sign up and download it. The full version is actually available as early access as Patreon stuff. This channel do not receive any revenue from Google Ads anymore, so this is the only way how I can continue investing the time in the production of these videos. In any case, huge thanks for everyone supporting this channel by any means. Even with a simple like or comment, your support means a lot. Exteriors. We already have initial layout with containers down below and dimensional depo at the top. We need to make something in between to play around those conveyor lifts, and I had several ideas, but eventually one with the LED panels behind the lifts and steel beams in between was the one to go into the production. There is 27 meter gap between top and bottom of the blueprint, And I have made blueprint template with several angled beams and straight beams to give this box blueprint a bit of like three-dimensional oomph. For simple LED panels, I actually went with slow gradient. So from far away we can see this like nice light gradient effect from top to bottom. And next was the slow process of placing everything around the exterior with this blueprint. And good lord, we have the notch tool, because yeah, by using half steps with a lock mode we can actually make everything even, and the lock mode is accessed with button H, and for the half steps you need to hold Control. After making all the sides in the same style, it was time to check the resource tab. And yeah, it was real tab on my, it was questionable at best. LED panels require just too much reinforced iron plates and quartz. While resources in itself is not a big deal, running out of inventory space is a deal breaker. Consider that this is like tier 5 to 6, you definitely do not have maximum inventory space. It's just not feasible, it doesn't work. Although like one can argue for dimensional depot, but this is like sort of a chicken and an egg problem. I want to build blueprint to fill up my dimensional depot, but I need to fill dimensional depot to build this blueprint in the first place. Not ideal. I decided to reduce amount of LED panels almost in half, replace the side panels with a bunch of concrete pillars and just added some lights at the top. On the roof I'm using asphalt foundations to get that roofing felt look. Then I place angle sunroof windows, and the nice tip here is to just have some of those windows sort of like opened. This way it looks like a real thing, and also I can access those storage containers for motors, screws and portable miners if necessary. So there is the form and function, both of them. What a joke. Final bits were to add some side windows to a top blob of concrete, and I make a simple top binding with the road barriers. Up next I went for a bit lighter colors to offset the darker concrete tones. I'm using CSSgradient.io for my gradient setups, and I just copy and paste hex numbers into the custom color tool in Satisfactory. Do not use custom color presets, the actual color presets, because those are unique to every single game and will change the colors of your blueprint if you load it into another save. So it's not ideal, you need to use the custom color tool to actually set your colors in stone in the particular blueprint. Yeah, Satisfactory 1.0 is still suboptimal in some places, but you know. First I had the idea to wrap around the whole blueprint with a single gradient, but then I decided to go for something a bit simpler, so now every side have flow into each other and have the same repeating gradient wave. Alright, the blueprint is done. If you download one of my blueprints, you need to import it into your save file, so we go for the local disk C, which is our system disk, then you go for the users, here you have your username, A in my case, then you go for the hidden folder app data, so you need to actually see the hidden folders in Windows. Then we go for the local, after that factory game, saved, save games, blueprints. Over here we have the session names. If you have 0 blueprints done in your session, you need to make one new blueprint and then the session name will appear here, the session folder. You go for the session folder and just import 2 files of a single blueprint. One is the actual blueprint, another one is the settings and description, and that's it. You will have your blueprint in this particular save. As always, huge thanks for watching, have a nice one, and Yakez out.